Plymouth, I just want to check. Do you hear us at Plymouth? Hello, Plymouth. Plymouth, can you move your camera up? We have this problem in sociology. Plymouth isn't responding. Oh, hang on a second. Let's cycle. Privacy. Columbia, do you hear us at Columbia?
Yeah, we got you.
Thank you very much.
Yes.
Plymouth, do you hear us at Plymouth? Yeah, he's right. Let me show them. Come on, right when I'm there, like that. There we go. I want to put Plymouth up there. I want to see me on the back. I think I can.
You want the what?
Plymouth. Do you hear us at Plymouth? Plymouth.
What?
Raise your hand if you can hear us at Plymouth. Just raise your hand. Now what was that? Go ahead and change up the configuration. See, I went through the same thing in sociology class.
Is this where they're sending stuff?
Nobody's sending content now. Well, send content in a second. Push content and then stop pushing it. Let's watch what happens. Okay, sending. That's it. No one's sending content. Okay, I'm gonna give Plymouth a call.
Okay.
They don't even seem to act like class is even starting. Like,
It's like they don't even have the TV on.
when it comes up, getting to their correct, like they're like nothing, like it's not on. Their TV isn't on. I think their audio is in their TV. They're waiting for the broadcast to start, and it's already started.
Someone can't hear you.
Who? Plymouth.
You're gonna have to call her.
Okay,
You got her number, right?
it's on. Yeah, I do. It'll take a couple of minutes.
That's the same problem they had last semester. It wouldn't. They're doing something to their settings. And because it's worked off.
Can you hear Plymouth?
He's muted. Plymouth, can you hear us?
Yes.
So who are we missing?
Yes, we can hear you. Yes, we can hear you.
You can hear Plymouth.
Everybody has the same password, so you can really hack into the school account.
Plymouth
You
can't
really
hear.
can hack into the school account.
Do you hear us, Plymouth?
Just it should be
They've got their incoming muted. Okay.
Are we missing? Are we missing?
Overcoat, maybe?
Yeah, we're missing somebody.
Yeah, overcoat.
Okay.
Do we know? Did you have any problems with overcoat earlier?
No. They dropped out. Didn't they? Drag them in. I'll drag you forward.
If you'd like to go ahead.
Okay. All right. I'm going to go ahead and get started. I wanted to let everybody know that our first test will be Friday. That's September 15th. Okay, Friday, September 15th. And that will cover everything in chapter 1 that we cover
We can't hear you.
and the review section. Uh-oh. Okay, so test is Friday, this Friday, but next Friday. Okay, so not this Friday the 8th, but next Friday the 15th.
Sorry, could you please repeat that? Ocracoke just joined.
Hey, Ocracoke, test is Friday, not this Friday, but next Friday, September 15th. So just heads up. All right, any questions about any of the
I got a question in Columbia.
Yes.
Is the test online or on paper?
Both. It will be on the computer, but I will have paper for you that are numbered 1 through, if there's 20 or however many questions there are, because some questions will require that you show me your work, like the completing the square problem. So you're going to complete the square on your paper, and you'll type the answer in on the computer. So your final grade will not be submitted until I get your paper and see your work.
Are we going to be doing the test in class or for honor?
You do not, those of you that are here do not have a computer available in this room. Those of you that are here could bring your own computer and take it at this time in the room. And for those of you who don't have that access, we'll go to the LEC and take it in the LEC. And if you don't know where that is, I'll help y'all out with that. Okay. Any other questions?
So it's over chapter 1, right? Does it go into the review sections?
Yes, it will also have some of the review. And I'm going to create a review that kind of reminds you of those things that were important in the review section also. So you'll have another chance to kind of see it all in one spot. Any other questions? Right. We started last time with section 1.6. We did half of it. And so today we're going to finish the other half of 1.6. And this part is dealing with radicals. So you'll see why I took and put some of those questions in the review part that had radicals, because this is what you're going to be dealing with here, and you're always having to factor. So those things were very important. So this is 1.6, part 2. Get my pencil back. So we're going to be solving an equation with radicals. So I like to give you steps when I can. So I'm going to start with listing the steps. So step 1 is going to be to isolate your radical on one side. If there are two, you'll get one on one side and one on the other. And then you're going to most likely square both sides. Most of the radical problems that we'll have will have square roots. So to undo a square root, you would square it. If it was a fourth root, you'd raise it to the fourth power. You do that to each side. And hopefully you'll get rid of all your radicals. Sometimes you don't, and you have to go back and repeat and isolate the radical and square it again. Once you get rid of all your radicals, you'll just solve it like usual. The problem is that when you get down to the bottom, you may have provided yourself with extra solutions. That's why they're called extraneous solutions, because, you know, when we were dealing with quadratics, we had x squared. And remember, we could have two answers, one answer, or no answers. Well, we raise each side of that equation to a higher power. We're changing it from being a square root to now squaring it. So we can have extra solutions in there that weren't true in the original problem. And so when you solve these, you have to go back and check, plug them into the original problem to see which ones work. Maybe all of them, maybe none of them, maybe one. Okay? Yes?
Plymouth see and hear us now.
Plymouth, can you see and hear us now?
Hello, Plymouth?
Okay. All right, so after you've raised each side, you're going to solve it, you're going to check it. So let's go through that process with a couple of these. Okay, so here we've got x minus the square root of 15 minus 2x. So step 1 is going to be to isolate that radical. And I'm going to move the radical over to the other side. So I'm going to add that square root of 15 minus 2x to both sides. So I've isolated my radical. Since that's a square root, I want to undo that, so I'm going to square both sides. And I'm being very careful to say square both sides. That's different than just squaring each individual term, okay? And you'll see that in a problem later on. So we're going to square each side. So this turns into x squared, and when you square a square root, you'll get what's inside, so 15 minus 2x. So that looks very familiar, like our previous homework. That's a quadratic. You're going to get it set equal to 0. And then you can use any method. If you're not told a specific way, you can choose any method that you want to. So factor if it's easy, and if it's not, then use the quadratic formula. With this, we can factor it relatively easily, especially since the coefficient of x squared is 1. So, oops, put my x in the wrong place. So a 3 and a 5, and I need a -3, a +5. Then you set each part equal to 0. So we have two possible solutions, but remember, because we squared both sides, we may have extra or extraneous solutions. So you go back, and we're going to plug the 3 into the original problem. Right, so when we plug the 3 into the original problem, we'll have 3 minus the square root of 15 minus 2 times 3, and we want to know, is that equal to 0? Okay, and so that is 3 minus the square root of 9, which is 3 minus 3. So yes, that's equal to 0. So 3 is a solution. I'm good with that. And then I'm going to do the same thing for checking for 5. So I'm going to go back and put negative 5 into the original problem. Negative 5 minus the square root of 15 minus 2 times the negative 5. And I want to know, is that equal to 0? Notice just technique, whenever I substitute a number in the place of a variable, it's a good habit to put parentheses around it, and that allows you to be careful, especially if that number is a negative number and you don't all of a sudden start subtracting it when you were supposed to multiply by a negative number. Just helps you be careful. So here, when I go through the process of this on the left-hand side and simplify it, I'm going to get a negative 10, and that is not equal to 0. So the only thing that will work is the 3. So your only solution is the 3. Yes. Sure. Any questions about any step there? Great.
Plymouth can hear you now.
All right, great. All right, with this problem, we have 2 radicals, 2 square roots. We want to isolate them, get one on one side and one on the other. So I would strategically move the one that had the subtraction sign in front of it, so I eliminate negatives when I can. So I've isolated them the best I can, so now I'm going to square each side. Notice I'm having to square the side. Squaring a side does not mean square each term. I'm going to actually have to FOIL the right side out. So the left-hand side is easy, 2x plus 3. But the right-hand side, all right, what's happening here is you're saying 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. That's what's happening. I'm foiling that, okay? So 1 times 1, that's going to give you your 1. And then I'm going to have square root of x plus 1 plus the square root of x plus 1, so I'm going to have 2 of those. And then the square root of x plus 1 times the square root of x plus 1 is just x plus 1. Yes?
I thought the whole purpose of squaring it was to change it to without the square root.
Yes, that is totally the purpose. And the thing, I can't walk away because they can't see me when I walk away. All right, so that's what happened on the left side, right? But on the right side, I can't just square individual pieces. I can't just square those individual terms because that's not algebraically equivalent. So I actually have to square that whole side. So the goal is exactly what you said. It's just I'm going to have to repeat myself again. So remember in our steps there was that one little thing that says you might have to repeat. I'm going to have to repeat right here because I still do have a radical. So now I'm going to move everybody that's not a radical on one side and everybody that is with the radical on the other and start over again. Yes, so now, just like I said, we still aren't done because we still have a radical, so I have to isolate that radical. So this is the repeat part, okay? So combine like terms, move everything that you can over to the other side, and you'll have x plus 1 is equal to 2 times the square root of x plus 1. So I just simplified there. So I have to repeat again, squaring both sides. And notice I'm squaring that left-hand side, so really I'm saying x plus 1 times x plus 1. I'm foiling that left-hand side. Okay, if you don't do that, you're going to lose that middle term, and you're not going to get the right answer. So you have to foil that left-hand side. The right-hand side, now because this is 2 times the square root of x plus 1, you are squaring each factor there. So that becomes a 4 times an x plus 1. So I'm going to let you soak all those steps in before we go on, and let me know if at any step you aren't sure. Any questions? All right, so there's a lot of rules that's going into play here. So now I'm just going to distribute my 4. And you see I have a quadratic, so I get it set equal to 0. Then you just factor. And you get 2 choices. You have a -1 and you have a 3. And just for time's sake, I will tell you that when you check x equals -1, you plug that back in to the original problem. This one does work. And the same thing for 3. When you plug it back into the original problem, it also makes a true statement. So you have 2 answers here, -1 and 3. Okay, so when I say check, you're taking that number, going back to the original problem, and just leaving it like it is and seeing if the left-hand side equals the right-hand side. Any questions? So again, I have 2 radicals. They're already isolated the best they can be. So what am I going to do to both sides? Yep, square it. I'm going to square each side. I'm going to give you just like 30 seconds to do that part. Square both sides. Because this is important. If you don't do this step correctly, then your answer is not going to be right. Yeah, you can keep going if you're just waiting on us. So when you do get that first foiling done of that left-hand side, check yourself and see if you have the same that I have written down. X plus 5 plus 4 times the square root of x plus 5 plus 4. So see if you got that little part right there correct. Any questions about that step? Okay, we still have a radical, so now we've got to move everybody over and isolate that radical. Yes.
Okay, I think I'm not the only person maybe,
Okay.
but I'm a little confused with how you're squaring the first part of that.
Yes,
and getting that number you got.
The left-hand side?
Yeah, like
Okay.
I'm kinda
Thank you for asking. All right, because if you don't ask, I don't know. All right, so here we go. I'm going to do it step by step. All right, I'm going to do it. I'm going to have the square root of x plus 5 plus 2 times the square root of x plus 5 plus 2. So are you okay with me setting it up like that, that's actually what we're doing, right? We're squaring the whole side. Okay, so I'm going to FOIL it out. So I've got the square root of x plus 5 times the square root of x plus 5. So that's going to just be x plus 5. You okay with that?
Okay.
Awesome. All right, and then I'm going to have the square root of x plus 5 times 2. So that's going to be 2 times the square root of x plus 5. And then I'm going to have 2 times the square root of x plus 5 again. And then I'll have 2 times 2 and get 4. So those middle two terms are like terms, so I can add those together. So that's why this part right here becomes 4 times the square root of x plus 5. Scroll down. So that's how I have x plus 5 plus 4 times the square root of x plus 5 plus 4.
Thank you.
You're welcome. All right. Any other questions about that step? All right. Okay. So once I got there, I have that square root. I need to isolate, move everybody else over. Now, if you're being a good detective and you see what's going on right here, you would notice that the square root is never going to equal a negative number. Okay, because if the square root is written on the piece of paper, it's understood to be positive, unless you're told something like we're dealing with complex numbers, but if it's on there, it's understood that give you a positive answer. So you could stop right here and say there's no solution, okay, if you recognize that. If you didn't and you kept going, you're going to get to that same answer. But so let's keep going. So if I were going to keep going, I would need to, I could, if I wanted to, divide both sides by 4. I didn't on the last problem, but I did this one because it doesn't matter. Okay. I'm going to square both sides. And that's going to give me what on that? Now, the 10 over the 4, I could reduce that to negative 5 over 2. Always make your numbers smaller when you can, okay? So that's what that actually equals. So then that's going to give me a 25 over a 4. Yep. So x is going to equal 25 over 4 minus 5. And so x is going to be 5/4 because 5 is the same thing as 20 over 4. So 25 minus 20 gives me 5 over 4. So 5 over 4 is what I want to check. So I have to check this. So to check that, I would go and I would take 5 over 4, plug it into the original problem, but it's not going to work. So when you check this, x, when you plug x equals 5 over 4 into the original problem, it is false. So therefore, there's no solution to this problem. So when I say it's false, that means if I plugged it in, the left-hand side was not equal to the right-hand side. Yes?
Is that like ever gonna happen on like the website where we get no solution?
Yes. Like in my math lab, you mean? It could. I would say it was, yeah, I would expect that one of your homework problems probably would tell you no solution. Now, when you sit down to work a problem and when somebody else sits down to work a problem, they just randomly give you numbers and give somebody else numbers. So it could be that yours spit out so that yours got no solution, but the person beside you spit out so they got 3 was their solution, because they'll change numbers. Same problem, different numbers. Yes?
If you scroll up some more, I've been like staring at it. I really can't figure this out.
Sure.
If I'm missing something.
Mm-hmm.
The line where it's x plus 5 plus 4 square root, blah, blah, blah. Right above -10. See it?
Yes, the big long line at the top of the page there?
Right.
Yes.
How did you get to the next line?
Okay. So what I did was the first thing, I subtracted x from both sides, and that meant my x's canceled out. So I'll write that.
I just thought you can break up those after they're under the square root. I thought you could break that up.
Oh, you can. Once it comes up from under the square root, it's free. You've set it free. So yes. Mm-hmm. Yes. Because you're right, if things are in parentheses and it has like a square or something on the outside, they have to stay together. But once you can get rid of that power, it can do whatever you want. Any other questions? Okay. Okay, so this time instead of a square root, I have the 4th root of x squared plus 6x. Same steps. Isolate your radical. It doesn't matter what square root, 6th root, whatever root it is. The radical is isolated. So this time, what power do I raise each side of that equation to? 4. And once you do that, you have a quadratic. And so you'll get x is equal to 2 and x is equal to -8 by setting each one of those equal to 0. And you still have to check them. And checking would mean going back and plugging that into the original equation. And it turns out that they both work. All right. All right, x to the 3/5 equals 27. When you have a power that is a fraction, really, that's a radical, right? Remember, that was in some of our review work that you did. I'll remind you real fast. So if I have x to the a over b, then this is the same thing as the bth root, the raised to the a power, or take the b root of x raised to the a power. So I know that's a lot of variables, and sometimes people are like, that just looks like vegetable soup. I'm not quite sure. Let me put some numbers here. If I have x to the 3/5, just like I have up top, what this means is I'm taking the 5th root of x to the 3rd. Or I could write it as the 5th root of x raised to the 3rd power. Both of those are equivalent. Okay? So when you see an exponent that is a fraction, it's really it's a radical. So we have x to the 3/5 equals 27. So I'll rewrite that. So if I want to undo that power, right, think about what we were doing before. If you have the 4th root of x, another way to write that is x to the 1/4, right? They mean the same thing. What were we doing to both sides of that equation before? We raised it to what power? We raised it to the 4th power, because when you raise this to the 4th power, when you raise powers to powers, what do? Multiply. So that's how we got it to undo itself and just be x, right? X to the 1st power. So we're going to do the same thing here. And so that's not really equals. That's just showing you what would happen if I raised each side to the 4th power. All right. So what I want to do is raise each side to some power. What power would make this exponent on that x become a 1? So this would be true if I were adding it. But you're thinking right. But instead of adding it, when I raise powers to powers, I multiply. So what do I want to multiply 3/5 by so that it would become a 1? 5/3. So I'm going to raise each side to the 5/3 power. That makes my left-hand side just become that x to the 1st power. And then I've got to decide how I'm going to do 27 to the 5/3. Now you have a calculator which can spit that out for you. However, it's also important that you understand what is going on. Remember, the whole 27 to the 5/3 is the same thing as, make sure I wrote that down right. I didn't flip it, did I? Yes, 5/3. All right, so what I want to do is figure out the cube root of 27 and then raise it to the 5th power. See, I wouldn't want to put that 5 on the inside, because I would be saying 27 to the 5th power, and that would make that a very huge number, and then I'd have to find the cube root of that, which is fine if I'm using my calculator, but if I'm just having to do it on my own, that would make numbers very large. So what's the cube root of 27? 3. And 3 to the 5th power is, y'all check me, 243. Yes. All right. So 243 is your answer, and you should, since you raised that each side to a new power, you should check it and make sure that it does satisfy the original problem. It does. Okay. I'm just trying to show you different ones so you'll have a plan of attack. All right, we've used substitution before a couple of times. Now we're going to use it to turn an equation that has a bunch of radicals in it into a quadratic. Now these instructions right here, this tells us to use substitution. And your homework may or may not tell you to use substitution. But notice something. If I were to try to isolate these radicals, all the other times we've isolated radicals, It's been a square root and a square root, a fourth root and a fourth root, right? This is a 2/3 and a 1/3. They're not exactly the same. Okay, so things have changed just a little bit. I can use substitution when, notice my bases here are the same, right? And let's compare these exponents. One is twice the other. See that? Times 2 is going to give me 2/3. So that's the setup that you have where using substitution is helpful. When we use substitution, remember we said we often use that letter U. So I'm going to let U be equal to x plus 1 to the 1/3. So you let it be equal to that entire middle term. When I do that, this becomes U squared minus U minus 2. Okay, so soak that in for a minute. See if you have any questions about rewriting that. Right. So you see, once we've done substitution, it's a very simple situation where we can just factor that, hopefully. Right, so U would be equal to -1, or U could be 2. But our original problem didn't have U's in it. So I can't say that that's my final answer. I have to go back and tell you what the X is supposed to be. So in the place of U, you go back and you write X plus 1 to the 1/3 equals a -1. And same thing for the 2 part, you'll have X plus 1 to the 1/3 equals a -1. So in your notes right there, you might want to remind yourself, hey, don't forget to go back and rewrite U in terms of X, because the original problem was all X's. I'm not finished. All I've done now is say I have X plus 1 to the 1/3. So what have I got to do to both sides? Raise it to what power? Third. So I'm going to raise each side to the 3rd power. And do the same thing for the 2. And then you need to check each one by going back and plugging them into the original problem, which you have your calculator, so that shouldn't be that difficult to do. So these problems can be tedious, so just make sure that you're careful with all your signs. Don't stop at U's. Got to keep going to all your X's. Any questions about any step in that problem? I'm trying to choose problems where maybe you might have a question about as you get to doing your homework. This one says x minus 8 to the 2/3 equals 9. What am I going to do to both sides? We did one similar, so what am I going to do to both sides? Raise it to what power? 3/2. So be careful right here. Whenever you have an even number in that little denominator, remember that would represent a square root, right? So we have to be careful about that, because remember, whenever you draw the square root symbol, you have to remember to do plus, minus, right? So that's essentially what you're doing here. You're taking 3 halves, and that little 2 on the bottom means you're really taking a square root of something. So we have to be careful with our answers. So the left-hand side is going to be x minus 8, but the right-hand side is going to be the square root of 9 cubed. And because you are taking the square root, you have to go plus minus. So really what we've got is x minus 8 could be equal to, and this is a plus minus 3 cubed, which is x minus 8. And if it's a positive 3, you get a positive 27. But if it's a negative 3, you get a negative 27. So you actually have x minus 8, and that could be equal to a positive 27, or x minus 8 could be equal to a negative 27. So you have to do both of those choices. So that's going to give you, let's see, if it's a positive, you're going to add 8, so that's going to give you 35. And add 8, that's going to give you, is it 19? So you have 2 choices there. Again, you go back and check each one of those. And I think they both work. I don't have a note here otherwise, so I think they both work. But I do that one specifically because I think there's one in your homework like that. And if you didn't catch the plus minus thing, you would say, what have I done wrong, and how did they come up with 2 answers? But it's because underneath, that's when you have a 2 or an even number, that's representing an even radical, okay, an even root. I'm just going to give you one more where I want you to try to set it up using substitution. So determine what your u should be and rewrite what it would look like if it just had u's. So remember, when I'm looking at this problem, if it didn't tell me what to do, first of all, I think it looked very complicated. Second of all, one is to the 2/3, the other is to the 1/3. They're not the same, so that also tells me I need to do something a little different. Both of them have the same base, so that lets me know, hey, I might could use substitution. And then when I see that this term, this exponent, and this exponent, one is twice the other, I get to use substitution. All right? Remember, that's twice the other. So you let u be the middle one, so, or the one with the smaller exponent. So that's why I let u be 2x minus 1 to the 1/3. And then I can write the problem as u squared plus 2u minus 3. Okay? And then you can factor. Don't stop there, because our problem had x's, and the x, remember, was 2x minus 1. So 2x minus 1 raised to the 1/3 equals 1, and 2x minus 1 raised to the 1/3 equals a negative 3. Cube each side. And when you substitute the 2x minus 1 raised to the 1/3 and then cube each side, don't forget you need to check. And they each work. So you have 2 answers. Any questions? Okay, so I tried to do all the different types that you would see in your homework. Stay up on your homework. And don't forget that your test is on the 15th. Okay, have a good afternoon.